Okay, so I want to break down this logarithm format. This is the base, okay? That's the thing that's going to get the exponent, all right? And here's the exponent out there. It's equal to the exponent. A logarithm is an exponent. So when you ask for a logarithm of base b, it says, what am I going to raise the b to? This time they picked the right letter, b for base. What am I going to raise the b to? And the answer is x. I'm going to say b to the x power, and that's going to get me my desired result, which is also called the argument. Okay, it's the thing I ask about. I say log base b of y. Well, y is my desired result, okay? So if that seems kind of backward and funny, well, that's just how it is. So when you look at a logarithm, that's what you're supposed to think. All right, so we can go, and maybe I didn't want to get rid of that. Maybe that's okay. They wrote it, but anyhow. So we look here and we say base 2. So there's my base, and here's my exponent. So I put it on the 2, and what do you know? I actually get an 8. 2 to the third is 8. And I say my base is 4. And my exponent is 0, so I have 4 to the 0. Anything to the 0 is 1. That was my result that I was looking for. 1. Perfect. It all works out. And you can see these examples, how this works. And, you know, you cannot ask for a 0 or a negative number. So these guys can't be negative or 0, okay? The desired results can't be. But if you give it a negative exponent, you can't make it negative by doing that, but you can make it small, okay? And or if it's already small, here we have a base of 1/4. That's already small, so that flips the 4 up on top, so now it's big. So I guess it's contradicting what I said, but normally a negative exponent makes things small unless they're already a fraction, and then they turn it upside down. Okay. So it's kind of a strange example there, but it's true. So rewrite the equation in exponential form. Well, I know what my base is. It's 7. And I know what my exponent... So let me just write base here. Base. And I know what my exponent is. It's what the log equals, because the logarithm is an exponent. Why don't we just call it an exponent? Well, I don't know. This is how we do things. Is equal to the desired result. Is 7 to the 1... equal to 7? Yes, it is. And that's the exponential form. You say, that's just bordering stupid. Well, that's how it is. So my base is 1/2. Okay, so I'm going to put parentheses, because otherwise I won't know what's going on. And so that's my base. You know this. This is the base, and this is the exponent. So what does the negative 5 do? Well, the negative 5 goes on the 1, and it also goes on the 2. And it tells the 1 to go on the bottom and be positive, have a positive exponent. And it tells the bottom to go on the top and have a positive exponent. And 1 times 1 times 1 times 1 times 1 is still 1. So I'm going to have 2 to the 5th, which is 32, over 1, which is just 32. So after all that, I proved it, so let me write it now the way I was supposed to. 1/2 to the negative 5 is equal to 32. This is what they asked me to do. I was just showing you that it's true. This is the exponential form. Okay?